All right, so the next type of sequence is called as geometric sequence. And we obtain the geometric sequence terms by basically like multiplying by a fixed number. So if I multiply this previous term, which is 4 by 2, I get 8. If I multiply 8 by 2, I get 16. If I multiply this by 2, I get 32, and so on. So when you talk about the geometric sequence is basically the common ratio. Now, it has got a common ratio. Now, how do you find a common ratio? Okay, um, so when you find a common ratio, it is basically 8 over 4. So 8 over 4, if it is equals to 16 over 8, if it is equals to 32 over 16, and so on. That's what is a common ratio, which is 2. And for any sequence that is true is always going to be the same. So any geometric sequence. Um, so let's say if you have got here, let's say there's 3, 3, and so on. So we got like the same common ratios. So it is 3 times 3 is 9, 9 times 3 is 27. 27 times 3 is basically the next term. So when you talk about the nth term of this particular sequence, we get here the formula is, if I represent un, is nothing but u1 times ratio to the power n minus 1. So this is the general formula. So u1 is the first term, n is the term that you want to find out, and r is the ratio. So what we do is basically, if I look at 3, 9, 27, and so on, here the ratio is 3. And so my nth term is going to be first term, which is 3, times ratio, which is 3 to the power n minus 1. And if I simplify it, it becomes this, 3 to the power n using indices property. So 3 times 3 to the power n minus 1, it is 3 to the power n. So that's how you basically find out the nth term of geometric sequence. Now, a general mistake that we do is like figuring out that, okay, ratio can be only positive. I mean, if you look at here, its ratio is -2 every time. So if that's happening, it's okay. The ratio can be negative. So -2 times -2 to the power n minus 1. And that's what is your nth term here. So when you talk about the nth term formula, you get u1 times ratio to the power n minus 1. And just to take some more examples on this particular type of question, I'm just going to take some more examples from the DP syllabus. Here is the first example. The type of question that is assessed is, okay, if you've got k minus 1, 2k, and 21 minus k, these are the consecutive terms of the geometric sequence, find out the value of k. So it is going to be here 2k divided by k minus 1, and this 21 minus k divided by 2k is basically the same because they're the common ratio. So 2k over k minus 1 equals to 21 minus k over 2k. And next step is to solve for k. So when you cross multiply this with this and this with this, you get this step. And you open the brackets, you're going to get this. And you get solve factor quadratic and solve. You get the values of k as 7 over 3 or k is 3. So that's how you get the entire expression. I mean, the two sequence possible. So here, this one is with the ratio 7. Here is with the ratio 3. So that's a simple example on the geometric sequence. Now let's take one more example that is little advanced. So if I take this example here, I'll take the fifth one. So in the fifth question, they say that 8, 4 root 2, 4, 2 root 2 is a geometric sequence. Show that the general term formula is this. Now for this question, you require a little bit of knowledge about the surds and indices. Now I'm going to take simply the first definition. Nth term of the geometric sequence is u1 times ratio to the power n minus 1. Now here, my u1 is basically 8. Now when I find out the ratio, it can divide any previous term. I mean the 4 root 2 divided by 8. So that's gonna be this get cancelled. Here is 2. And if I take root 2 over 2, and I can write down this 2 as, I mean, you can keep it this way itself. So root 2 over 2, this is the answer for ratio. Now what we get is the nth term formula. So when you write on the nth term formula, it is 8 times a ratio which is root 2 over 2 to the power n minus 1. So 8 is basically, now you got to simplify and show it is in this. Now you can see you're writing its power of 2, so you got to write every term as power of 2. So if I can write down this as 2 cubed times, now this is 2 to the power half to the power n minus 1 and times 2 to the power negative half to the power n minus 1. So if you bring it up, it becomes 2 to the power negative 1. So now you got 2 to the power n times 2 to the power n minus 1 over 2 times 2 to the power negative n plus 1, because if you multiply. So you get, if you simplify this and add the indices, you get n, sorry, this is 3 here. So there's 3 plus n minus 1 over 2 and minus n plus 1. So if you simplify this, I'm pretty sure you're going to get 2 to the power 7 over 2 minus half n. So that's how you find the nth term formula for this particular geometric sequence. Now I'm going to take one more example. So here's another question on the geometric sequence. Now this is one of my favorite questions for DP. The geometric sequence has second term as negative 6 and fifth term is 162. Find out the general term. Now second term is negative 6 and fifth term is 162. So when you talk about the second term is negative 6, now what we got to do is here, first you got to write in the formula u1 times r to the power n minus 1. So if you compare, my second term means n is 2 here. So u2 is u1 times ratio to the power 2 minus 1. So what we get is, and this answer is negative 6. So u1 r to the power 1 is negative 6. And similarly, if I've taken as 5, so u5 will be u1 times ratio to the power 5 minus 1. So u1 times ratio to the power 4. So what we get is u1 ratio to the power 4 equals to 162. And so what we eventually got is the two equations. So the two equations are, the first one is u1 times r is negative 6, and second one is u1 r to the power 4 is 162. Now, how do I solve this equation? Actually, I ideally like to make u1 the subject from one of them. So if I take u1 the subject, it is negative 6 over r, and you replace with this u1. So this u1 is actually negative 6 over r times r to the power 4 is 162. And one of the r get cancelled, and so you get negative 6r cubed equals to 162. And that gives you r cubed is negative 27, and r you get is negative 3. So that's one possible way. Now to find out u1, you can substitute this in one of the equation, r as negative 3. Now what you got to do is, like if you look at the other alternate ways, once you get the two equations, like this one and this one, you could just divide left hand side and right hand side. So as a rule, if you guys can remember, a equals to b and c equals to d, then a over c equals to b over d. So u1 and u1 get cancelled, and you get r cubed equals to negative 27, and so whichever way you like. And then finally the nth term formula is u1 times ratio to the power n minus 1. So that's how you find out the general term formula for the geometric sequence. I hope this is helpful. And next part is going to be on the arithmetic and geometric series.